Hey, welcome back to Math with Patrick. It's April 23rd, and we're solving problem number 113 from the Daily Epsilon calendar. And so I have this first equation here that tells me maybe what this value t is. And once I figure out what that value t is, I could plug it in here, and then apparently this is the number 23. Because usually in these problems with no instructions, you're supposed to solve for x. I do notice that today's date is the 23rd, and then the number 23 shows up a whole bunch, and the number 24 is right next to the number 23. And I have this hunch, this guess that this 23 isn't too special. Like maybe if I replace these with fours and then these with fives, because it's one greater, then I would end up just getting the number 4 here. So let's just solve it directly first, and then I want to see if that guess, that hunch, is actually correct. So starting here, we have 1 divided by t plus 23 is equal to 23. And this already shows me that this number right here is going to be some very small number. Because I'm doing 1 and then divided by something gives me a big number. So I essentially need to fit a whole bunch of small things in the number 1. And actually, I need to fit 23 of them in the number 1, kind of thinking about this fraction as a division problem. So that actually just shows me that this number here should be 1/23, because I know that, 23 of this number fits in the number 1. And again, thinking about fractions as division tells me that that's the case. So I could just write t plus 23 is equal to 1/23. Another way to think about this is it's kind of like a fact family with multiplication and division. So let's just take 4 times 6 equals 24 as an example. I could also write 24 divided by 6 is 4. Or I could have just as easily swapped these numbers. And so I can just put the 6 back there and the 4 under here, and it's still a true equation. So anytime you have something like this, you can always just swap this value with that one, and it's still going to be true. So that kind of helps me solve for t. I guess I just need to subtract 23, and then I get my value. T is going to be 1/23 minus 23. Not the friendliest of numbers, but I'm just going to try to plug that directly into this fraction right here and see what happens. 24 over, and then I'm debating whether or not to put parentheses around it. I don't think I need them right now, because after I do that subtraction, then I'll add the 24. And so parentheses or not, I'm still going to just do all my operations in that order. And this is supposed to be equal to x. Cool. Simplifying the bottom, I just see that there's a negative 23 or a minus 23 plus a 24. So together that just makes the number 1. And I still need to figure out why this fraction matches today's date, which is, 23. Whenever I see fractions within fractions, I always try to find common denominators. And so if I take this 1 and I call it 23/23, that's just a fancy number 1. But it does allow me to add my fractions together. Now that they have the same denominator, I could say that this is 24 over, and then 24/23. And now it's basically just some fraction math. Maybe writing this 24 as 24 over 1 could help. Again, thinking about fractions as division, this is the same thing as saying 24 divided by 24/23. And then usually fraction multiplication is a little bit easier to think about than fraction division. So all you really got to do to change those is you just can change division to multiplication as long as you take the reciprocal of the second fraction. Kind of like swapping both of these things undoes the other one. Like we swap one and swap the other, and it just kind of doesn't really change anything. And then finally, I can see that this 24 on top cancels with that 24 on bottom, and I'm just left with the number 23 today. So doing the arithmetic, not too bad. The answer is 23. Let me just double check my hunch that this 23 isn't really a special number, and this hopefully could have worked with, any number, not just 23. So again, I'm claiming that this 23 isn't anything special. And so if I replace all of my 23s with x's, I'll get something like this. And then I'll replace all my 24s with x plus 1s. And then I guess my claim is that it didn't really matter that we had the number 23. We're always going to just get x back right here. So let's see, I'll go x plus 1 on the top. That's this 24 right here. Then t, looks like t is right here. And I should probably like shuffle those numbers around just to solve for t again. 1 over t plus x equals x was the initial condition that we were given. And then I swapped the x for the t plus x denominator. And then to isolate t, finally, I just subtracted x from both sides. So I got something that looked like that. Okay. So t, this one right here, t is equal to 1 over x minus x. And then finally, I have an x plus 1 right here. So I'll go plus x plus 1. So kind of erasing all of these things. Yeah, again, my claim, I just want to show that basically this whole fraction is going to return an x. So let's try it out. I'll just follow the same steps essentially as before. You know how I like simplified that, I think the 23 and the 24? I was just left with a plus 1. That's kind of what's happening here. Minus x and plus x. I'm just going to be left with a plus 1 down there. So x plus 1 over 1 over x plus 1. Then I found a common denominator, and so it was with this 1 right here. I just called that, I think that was 24 over 24, or maybe it was the 23s. I already forget at this point. But either way, I want to find some common denominator this way. And then I was able to add the numerators and keep the denominators the same, or the denominator, singular, the same. And then finally, I said, oh, let's just pretend that this is fraction division. And then finally, I wrote that. And then instead of with division, I wrote it as multiplication. And then I took the reciprocal of the bottom fraction. And so it looks like, yeah, it doesn't really matter what number we have today. Although maybe it couldn't be like -1, because then I'm like dividing by 0 right here, and that's kind of strange. So I can just kind of go cross and cross off these factors as long as x isn't -1. Maybe that would kind of break this claim that any number here works. Also, I'm noticing here 1 over x, I'm dividing by x. So maybe when x is 0, that's also kind of shaky. So let's just kind of double check what happens there. So yeah, if like this is a 0 and this is a 0, I don't think, yeah, I can't make 1 over a number equal 0. It's just not going to work. You could try plugging in a large number like a million, but 1 over a million still isn't 0. You could try plugging in a negative number, but that's still not 0. So looks like this number right here couldn't have been 0. And then if it was -1, I don't yet see the issue here. Maybe something would happen with all the algebra. I'm not quite sure. I don't really care to look into it too far, but I just wanted to know that in general, if you just kind of plug in some number here and then add 1 to it and plug it in there, you're just going to get the same value that you started out with. So cool. Solving it with arithmetic, solving it with algebra, either way, we can tell that the answer is 23 today. So thanks for solving it with me, and I'll see you tomorrow. Bye.